Hello everybody, this is Max here again. I know I told you last time that I was going to show you in sort of an evaluation type of a tool, but I ran across this dandy little tool. It's let's say that you were a state agency and you had teams of folks that would go out. You subcontracted these things out to uh, for audits of agricultural acreages so that you could estimate what the savings would be if they uh, repaired certain uh, trouble codes or problem codes, and that's what these codes are here. This is where the crop is, the type of irrigation system, including center pivot further down. If you took care of the 18 acres, the 26 acres, or whatever the acreage here is, you could get this much savings. And so what the tool does is it models, if you had a certain budget, and these estimates, by the way, what happens with these is the audit teams go out and they identify issues and they make recommendations. Sometimes those recommendations are done, sometimes they're not, sometimes they're done piecemeal. In any case, they go back and they figure out what the real savings is due to fixing those things, so they have a pretty good idea what these savings or these problem code fixes can deliver. So you're an agency, you've got all these potential projects identified, and you go out and you have a bunch of sites here. So these are the changing cells that you're going to see in the model. So the model decides how many of those projects can be done within the constraints. So what is the model doing here? It's trying to maximize this savings, which is in D4, maximize, by changing the variable cells that I just showed you. And the budget here has to be less than the total budget here. And each project has to be, or project selected has to be less than or equal to 1, and has to be an integer. So you can't have parts of projects. So we're assuming here that all the projects are taken care of. So let's go back here and mess around with this budget. Let's say we don't have a lot of money, so let's say we have $1,500,000 to handle this, to grant out to these producers to be able to make some of these fixes on a wholesale basis. So let's run the model and see what it comes up with for $1,500,000. Okay, it came in at $87,200 and delivers a savings of 604 million gallons. By the way, this is not an MGD. I changed that, so this is a million gallons over the whole period, whatever that is. All of the projects were selected. In other words, according to this, ag conservation is pretty inexpensive. For $87,000, you fixed and delivered 604 million gallons. So that's it. I just wanted to show you this real quick. It's very informal, and I want to keep these informal. If you have any questions, let me know. I will show you an evaluation. I got two types of evaluation tools using something called data envelopment analysis. It's a pretty cool thing. Have a good day.